Hello, Year 9. So here we're starting on our second topic, chemistry. I'm going to be teaching you this one lesson by lesson, which is what I prefer to do, but it's probably a nice change to try something different and do the project work. So here's our folder here, lesson 1 elements. Before you start, as you can see, in the main folder and in here I've put a file called best periodic table. Now I'd like to open this. So I'm going to close it so you can see what I mean. I'd like to open this. It might open the wrong way around. So if you zoom out by clicking this here, or by holding Control and mouse scrolling out. Now, if you go to View, and then you go to Rotate View and clockwise, that will be the correct way up. Now this is the best periodic table because this will be the one that you will be given in your actual exam. So in your GCSE exams, this is the table they give you. So if you get used to this one and what information is on there, I think it's better than using a different one, but if you find a different one, that is fine. Just make sure that if you find one on the internet, the atomic number is on the bottom and the relative atomic mass is on the top, because the American ones are backwards for some reason, and they have it the other way around. I have no idea why. So I'm going to minimize that for now, and we're going to start with the PowerPoint. There are a few files here that are kind of optional, but I'm leaving it to your discretion because normally in the lesson I'd be able to figure this out for myself, based on which student remembers which. If you, for example, are struggling on certain things, I will tell you which bits to go to, but I'll leave it to your discretion to do them. Now, before we start, I'd like you to go and find a definition for element, compound and mixture, preferably from AQA BBC Bitesize. But we should remember what they are. If you want a bit of a recap, I'd like you to watch this video here. It'll tell you about atoms and elements. But hopefully we know that an element is made up of one type of atom only. So let's say a tripod made of iron. If you were to be able to look at the atoms, you would find that there would be only iron atoms in that tripod. And that is a pure element. Now, this is the periodic table, which you've seen before. Hopefully you know your way around it, but we are going to do a quick task based on this. So let's minimize that for now. Minimize this. Now, if you want to actually work through the task, periodic table worksheet is the task we're doing, but I am going to talk you through it now without the worksheet. So open up your periodic table. If you can't, you won't be able to edit a PDF. So if you can't print a PDF off, there is a Word document of the periodic table there, which you could try and edit in Word. But we need to know a few things about the periodic table. So let's move on to here. Now, first of all, possibly the most important thing that you need to know, this number up the top here. Okay, this represents the group number. That's a B-E-R. So, lithium, sodium, potassium, rubidium, cesium, and francium are all in group 1. Okay? Group 2, beryllium, magnesium, calcium, strontium, barium, and radium, all in group 2. Now, we're going to skip over this middle bit for now. Group 3 is here, which has boron, aluminium, gallium, indium, thallium, and nihonium. So you can see these are the groups. Actually, what do the groups tell you? They tell you the number of electrons in the outer shell. We'll talk about that later and why that's important later. The next thing you need to know is the period. Okay, so this, I'm going to do it in blue. This is period 1, which has only hydrogen and helium in period 1. Period 2 is here, is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. That is period 2. So this is the period. What does that show you? That tells you the number of electron shells. Again, I'm not going to tell you why these bits of information are important yet. It's just important to get your periodic table labelled. Now, the periods are quite important, but we don't use them as much. If you remember that the period tells you how many electron shells are there, then it makes later on drawing atoms and working out reactions a lot easier. So, sodium is in period 3, so it has 3 electron shells. Hydrogen is in period 1, so it has 1 electron shell. Now, there are a few names we need to learn. Group 1. So I'm just going to get my rubber and get rid of this. Group 1. I didn't mean to rub that out. Group 1 are called the alkali metals. Okay, group 1 are the alkali metals. So these, lithium, sodium, potassium, rubidium, cesium, and francium, are alkali metals. Group 7, okay, these are called the halogens. So everyone, fluorine, chlorine, bromine, iodine, astatine, and tennessine are halogens and all have 7 electrons in their outer shell, and group 0 are called the noble gases. So these, 0, it just means there is a full outer shell. They used to be called group 8. They changed that because helium does not have 8 electrons in its outer shell, but we'll get to that later. So group 8 all have, so group 0 all have full outer shells. Now that we've labelled the groups, well, we know that the groups 1 to 0, and we know the periods, we know the alkali metals and the halogens. You can label these ones the earth alkaline metals. You don't need to know that, but they are very similar to the alkali metals. Now, what I want you to do is start the next thing that we are doing, and maybe I will do it in, we'll try it in pink. I think it'll stand out a bit more. Between boron and aluminium, I'd like you to draw a line, okay? This is a boundary, and it's going to step down. So if you look here, it's going to step like this. There is my step. Let's just keep going. Right. This is the boundary between the non-metals. So everything this side of the boundary are non-metals. So that means boron, carbon, oxygen, silicon, phosphorus, sulfur, chlorine, etc. These are all non-metals. Everything on this side are metals. So lithium, magnesium, scandium, molybdenum, technetium, they're all metals. And the last thing I need you to label, this group here in the middle, the ones that don't have group numbers, these are called your transition metals. Okay, so now we've labeled everything in our periodic table. Now, going back to this pink boundary here, in reality, it's not quite this simple. Everything near the boundary, especially as you go further down, display some metal and some non-metal properties. You don't need to know that now, but just for the moment, see everything to the left of the line as a metal and everything to the right of the line as a non-metal. You'll learn a bit more about it later. Hydrogen is completely different from everything else. We call this a rogue element. That is rouge element. R-O-G-U-E, I believe is how you spell rogue. It's a rogue element because sometimes it acts like a metal, sometimes it acts like a non-metal, but it's a gas. How can a metal be a gas? You know, so it's really weird. So we have it floating by itself in the middle. Now, I know that took a while to label our periodic table, and you can always pause and have a little look at that. But this lesson will mostly just be a bit of recap from what you've done before. So today's lesson might be quite easy, but we need to make sure we've got these foundations completely solid before we try and build on some of the more difficult stuff. Okay, what's this? This diagram here on the left, I'd like you to try and describe it. So you can pause the video if you want, or think about it in your head. So let's continue. Right, you've got molecules of water. Notice this is a pure compound. It only has molecules that have one oxygen and two hydrogens. All of these molecules are identical. Okay, so you know this is a pure compound. You know this is a compound because you've got two different types of element bonded together. You've got hydrogen and oxygen bonded together. Okay. Now let's go on to chemical formula. So again, we're recapping a lot of stuff. H2O. Hopefully we remember a subscript 2 means that there are two atoms of hydrogen. Because there is no subscript number after the oxygen, there is only one oxygen. Really, we could write H2O1, but because we're scientists, we like to be efficient or lazy. We don't write numbers that don't need to be there. So let's look at this one. Pause the video, tell me how many atoms of hydrogen, sulfur and oxygen are there in this. Hopefully you've paused it. You should know there are two atoms of hydrogen. There is one atom of sulfur. There are four atoms of oxygen. Okay, so if I was to draw this one out, right, you'll have hydrogen, hydrogen, sulfur, 1, 2, 3, 4, oxygen, 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 right? So a visual diagram to help you. Two hydrogens, one sulfur, four oxygens. Okay. These are chemical formula for one molecule of that substance. Now, if I put a big 2 in front, what I'm saying is I've got two molecules of water. So if I was to draw that out, so HOH, so that's H2O. If I put a big 2 in front, what I'm saying is now, actually, I have got two of these. Again, if I put a 4 in front of this, I'm saying I have got 4 of them. I've got 4 molecules of that substance. Well, how many atoms in total? Hopefully you should know there are 3 atoms in total. There are 2 times hydrogen and 1 times oxygen atom. Right? There are 2 oxygen atoms here. There is 1 copper atom. There is 1 sulfur atom. And there are 4 oxygen atoms. This one, there are 2 hydrogen atoms. There are 1 sulfur atom. There are 4 oxygen atoms. Hopefully this is starting to ring a bell. Now, if I had one of these, I would have 2 hydrogen atoms. I would have 1 sulfur atom, and I would have 4 oxygen atoms. Now, this is a total of 4, 5, 6, 7. That would equal 7 total atoms. Because I've got a 2, that means I've got 4 hydrogens. So 2 of them equals 4 hydrogens, 2 sulfurs, 8 oxygens. So that gives you a total of 14 atoms, right? Hopefully this makes sense. If it doesn't, then we need to do a bit of practice on counting atoms up in compounds. Now, certain elements hang around in pairs. We call these diatomic elements. So you need to know that iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen are all diatomic. So if you ever write an equation that involves any of these as an element, say, for example, I had hydrogen reacting with chlorine to make to make hydrogen chloride. I couldn't just write H and Cl because I need to know that hydrogen and chlorine hang around as diatomic elements or molecules. Okay. I just remembered these because you use them so often that you remember them, but there's a nice little mnemonic. I bring clay for our new house. Okay. I, B, C, L, F, O, N, H are all the symbols for them. So, however you would like to remember it, but you need to remember them. More recap. Writing chemical equations. The top line, you have got a particle diagram. The second line, you've got a word equation. The third line, you have got a symbol equation. Okay, you need to know the difference between those three different things. You need to be able to write word and symbol equations. So let's have a look at this one. Magnesium plus oxygen makes magnesium oxide. Well, what's the symbol equation for this? I would like you to pause, I would like you to look at your periodic table, and I'd like you to try and come up with the answer. Okay, so let's unpause this and have a go. Well, hopefully you got magnesium as that. Hopefully you got oxygen as this, but remembered it was diatomic. And magnesium oxide is that. Now, you don't know why it's one magnesium to one oxygen yet. We will learn that eventually. If you are MgO2, that's a good guess. You would get 1 out of 2 marks currently, but later on you'll learn how to figure out what the formulas are. Now, we're moving on to balancing equations now. This equation here is not balanced. So I'm just going to skip out of this. Okay. I'm going to go into here. And I'm going to go new. Sorry, to open. Do not save that. Right. So, we just had magnesium. Magnesium plus oxygen makes magnesium oxide. Now, I would like you to draw a particle diagram for this. So again, pause it, draw your particle diagram, unpause it. I'm going to do it in green. So let's do this. Magnesium. There's my magnesium. I'm going to do oxygen in red. Oxygen, because it's a diatomic molecule, it looks like this. Oxygen and oxygen. And then my magnesium oxide, green, Mg, and oxygen. Okay, so let's go back to pink. That plus that makes that. Now, we have a problem here. If we go back and we remember the law of conservation of energy, or the law of conservation of mass, you need to know that energy or mass cannot be created or destroyed. It is only converted from one form to another. If you look at what we've got here, we have got 1 magnesium makes 1 magnesium, but we've got 2 oxygens only make 1 oxygen. So an oxygen has disappeared, and that can't happen. This equation is not balanced. So we're going to look at balancing equations. So underneath, what I like to do is I like to split straight down the middle of the arrow. On the right and the left hand side, I write the elements that I've got. So I've got magnesium and I've got oxygen. And I have to have exactly the same on the right hand side, otherwise the equation wouldn't work anyway. Right? Write them in the same order just to make it easier. Okay. How many magnesium atoms do I have on the left hand side? Well, you can either count the equation or count the diagram that you've drawn. You have 1 magnesium. How many oxygens do I have? Well, that's a 2, right? I've got 2 oxygen atoms on the left hand side. There's 1 oxygen atom, there's the other. I've got 2 oxygen atoms. Now let's go over to the right hand side, so everything to the right of this arrow. How many magnesium atoms do I have? I only have 1 magnesium atom. How many oxygen atoms do I have? I only have 1 oxygen atom. This is not balanced because, well, actually, the magnesiums at the moment are okay, but the oxygens are not. What am I going to do then? Well, the only thing I can do is put a big number in front of one of these things. Okay, I cannot change the small number. You might be thinking, this is the easiest solution. Okay, that you cannot do because that is not magnesium oxide anymore. You have changed it to be something else. Okay, so right, you can't have that. Now, what you've got to do is you've got to change the big number in front. So you find something you don't have enough of. So I do not have enough oxygens on my right hand side. Okay, I do not have enough oxygens on my right hand side, so I'm going to try to have more of them. What do? I put a big 2 in front of magnesium oxide, because what I'm saying now is I've got 2 of these. So let's draw. I've got another magnesium, and I've got another oxygen. Let's recount, because I've changed what's happened. So how many magnesiums do I now have? I now have 2 magnesium atoms. I now have 2 oxygen atoms. Okay, 2 of these means 2 oxygens, 2 of these means 2 magnesiums. Or look at your diagram and count up the atoms. 1, 2 magnesiums, 1, 2 oxygens. Well, the oxygens are now balanced, which is good. Okay, so let's have a look. I now do not have enough magnesium, so I need to do something about that. So what I'm going to do is I'm going to put a big 2 in front of that magnesium. So let's draw and recount. I now have 2 magnesiums on the left hand side and 2 on the right. So this is now a balanced equation. Okay, we just put that black so that when I rub stuff out it makes it go black. So we understand that now, hopefully. We're going to have plenty more practice with it, because it is, I think it's an easy skill, but it's very confusing to start with. What I'd like you to do is have a go at copying this equation and balancing it. I'd like to have a good go at it. You can look through the PowerPoint if you want, to try and get a method, but I'd like to try it by yourself. Pause the video, I will go through the answer in a second. So let's make a new. Right. Hopefully you've paused it and you've had a go. So we're doing magnesium plus hydrogen chloride. Right, this is the equation we've got. Magnesium plus HCl. That will make MgCl2 plus H2. So again, split it down the middle, like that. What elements do we have? Well, we've got magnesium, we have got hydrogen, and we have got chlorine. Do it exactly the same on the right. We've got magnesium, we've got hydrogen, and we've got chlorine. Equals. So let's count up. If you want to, you can draw your particle diagrams. But how many magnesium atoms do we have on the left hand side? Well, it's just Mg by itself, so we've got 1. How many atoms of hydrogen do we have on the left hand side? Remember, if there's no number next to it, it means there's a little 1 next to it. So we have got, okay, we have got 1 hydrogen and we have got 1 chlorine. Let's look at the right hand side. Again, Mg, no number, so it's a little 1 really, isn't it? We've got 1 magnesium. Here we've got 2 chlorines. And here we have got 2 hydrogens. At the moment, we're not really very balanced at all. Magnesiums are fine, hydrogens and chlorines are not. So let's go to where we figure out what we don't have enough of. Well, we don't have enough hydrogen or chlorine. So I'm just going to pick one. I'm going to pick hydrogen. We do not have enough hydrogen, so let's try and make it bigger. Well, hydrogen is in this compound here, so I'm going to put a big 2 in front of the whole compound. remember, that means now I've got 2 of everything inside these brackets. So let's recount. Well, before I had 1 hydrogen, but now I've got 2 of the whole thing. So that means I've got twice as much, so I've got 2 hydrogens. Again, before I had 1 chlorine, but now I've got twice as much because I put a 2 in front, so I've got 2 chlorines. Let's count that up. Well, magnesiums are fine. Hydrogens are balanced as well. Chlorines are balanced as well. So this is a balanced equation. Nice and straightforward. You just had to put 2 in front of the HCl. Okay, so that is sort of an intro to balancing equations. What I'd like you to try and do is this one. BE1. It's repeated on both sides because it just makes it easier to print. So just for each one, write it down. So here we've done, I maybe start with number 1. Some of them are quite difficult, so miss out maybe number 3 for a little bit because number 3 is quite hard. And work down and do maybe 4 of these. Have a go at 4 of them. Then try and do the last one as number 3 as your 5th. So in total you'll do 5. Pick 4, any 4, they're quite straightforward. Then try and do the chlorine plus aluminium one. Now, if you were struggling with the naming the compound bit, I need to go back to some key stage 3 stuff. Here is a naming compound task. If you are not sure, so this is making sure that if you've got the name of the compound, you can figure out what elements are inside it. If you're not sure, you Google the name and see what elements are in it. Okay. Here again, if you're struggling with using the periodic table, have a little go of this. Go through and find the symbols and answer these. The answers are on the right hand side. And that is everything for today. So there are a few optional tasks in there, but the main task is you go through the PowerPoint with me, which you've already done by listening to this video, and then answering 5 of those balancing equation things. Try and do 4 easy ones, and then do the aluminium one, which is more difficult.